The question is, if u is equal to 1 upon x square plus 1 upon y square plus 1 upon x square plus y square, then find the value of x del u del x plus y del u del y. Let us try to solve this question. We have given that u is equal to 1 upon x square plus 1 upon y square plus 1 upon x square plus y square. Let us give it equation number 1. Then we have to find the value of x del u del x plus y del u del y using Euler's theorem. Now, let us discuss about what is Euler's theorem for homogeneous function. So Euler's theorems for homogeneous function, if z is a homogeneous function of two variables x and y of degree n, then x del z del x plus y del z del y is equal to nz. Similarly, the second result, which is depending upon or which is based on the second order partial derivative, x square del 2z del x square plus 2xy del 2z del x del y plus y square del 2z del y square, which is equal to n into n minus 1 into z. So if we see the what is the in the question, we have to obtain the value of x del u del x plus y del u del y. Now, no need of this expression in this example, but when we solve the another question, at that time, if the higher order derivative, which is given in this format, is asked, then we can also use this formula. Let me take one example to check Euler's theorem for homogeneous function. What is the meaning of homogeneous function? Homogeneous function means a function in which each and every term has the same degree. For example, suppose if we have given z equal to x square plus y square plus xy. Now here, what is the degree of first term? Its power is 2, so degree is 2. The power of y is 2. The power of x is 1 and y is 1, so 1 plus 1 is 2. Since the degree of each and every term of these expressions are same, therefore z is called homogeneous function of x and y. Now, Euler's theorem states that if the function z, how to find out what is the degree of this homogeneous function? So now clearly in each and every term the power of like variables is 2. So the z is homogeneous function of x and y of degree 2. So if you want to find out what is the value of x del z del x plus y del z del y, this is nothing but 2 times of z or 2 times of x square plus y square plus xy. Right? So now at that time, even though without finding that partial derivative of z and with respect to x and y, we are able to say that what is the value of this expression by using the Euler's theorem. Okay, let us try to prove it is true or not. Let us first look here. We have given x z is equal to x square plus y square plus xy. So if you want to find out what is the del z del x, what is del z del x? It is nothing but 2x plus this is 0 and this is y. Similarly, del z del y, which is again this is 0, so 2y plus x. Now let us multiply this by x and this by y and adding them. So the left hand side will be what? It is x del z del x plus y del z del y, which is equal to 2x square plus xy plus 2y square plus xy. So we can write down this can be written as 2 times of x square plus y square plus xy, and this is nothing but what is this? This is z. So this expression, Euler's theorem, is true for all homogeneous functions. So now, if we have given such type of function which is homogeneous, they can then at that time, instead of finding the partial derivative of z with respect to x and y, or it may be extended for the 3 variable, 4 variable, n variable, we have to just write down its value like nz. N is the degree and z is the given function. So now here, let us try to first see that this is homogeneous function of x and y or not. If it is homogeneous function, then directly we can use the Euler's theorem and we will try to get the answer. Again, if you want to check that it is homogeneous function of and then how to get its degree, right? So let us see if we have like that. Say we will take the same example, x square plus y square plus xy. So what we can do over here, we can multiply and divide by x square because the degree of each and every term is 2. So x square upon x square plus y square upon x square plus xy upon y square. Sorry, x square. So x square, this x square upon x square is 1 plus this is y by x whole square plus it is x will cancel, it is y by x. So now just look here. The degree of this term is 0. Degree of this term is also 0 because the degree of y is 2 and degree of x is minus 2. Minus 2, so plus 2 minus 2 is 0. Here the degree of y is 1, degree of x is minus 1, so again 0. So if we write down like that, x square of f of y by x, so clearly what is the degree of, what is the power of this variable, which is the degree of the homogeneous function, because f of y by x has degree 0. So let us try to do the same method in this example. From equation number 1, we have u is equal to 1 upon x square plus 1 upon y square plus 1 upon x square plus y square. Now, what we are doing over here, let me just write down multiply and divide by x square here. Similarly, multiplying and divide by x square. And same thing we are doing over here, multiplying and divide by x square. So this x square will cancel. Here 1 upon x square upon x square, we can write down, we have taken 1 upon x square, 1 upon x square, 1 upon x square outside. So we have 1 upon x square, 1 upon this will cancel, 1 upon 1 plus 1 upon y by x whole square, and this will be again 1 and plus y by x whole square. Let me do it once again. This can be written as x to the power minus 2, 1 plus, we can write down y by x whole to the power 2. This is 1 and it is y by x whole square. So just look here in this side, the degree of each and every term is 0. So the total degree of this expression is based on this degree. So x to the power minus 2. So we can write down x to the power minus 2, which is multiplied with f of y by x. And this f of y by x is the function of y by x whose degree is 0. So clearly here u is a homogeneous function of x and y of degree minus 2. Hence, by Euler's theorem, x del u del x plus y del u del y, which is equal to nu, here n equal to minus 2, which implies x del u del x plus y del u del y, which is equal to minus 2u, because n is equal to minus 2, and we have the value of u is like this. So we can also put the value of u is 1 upon x square plus 1 upon y square plus 1 upon x square plus y square. And this is the answer. So the value of u del u del x plus y del u del y is equal to minus 2u, or we can put the value of u in this manner. So this is the desired value of x del u del x or ux plus y uy. Thank you.